All right. So, first things first. Let's write the formula that we're going to use first. So on your notes, the formula says that the mass of x, right? Mass percent of x, sorry, is equal to mass of whatever that x is divided by the total mass. And then we're going to multiply by 100, right? Just like the pie. So all you have to do first is to find the total mass. Can we find the total mass if we know that formula? Yeah. We can, right? So let's go ahead and write that out. So total mass is equal to C times what? 7. H times
14.
O times 2. So I'm just going to look these up on the periodic table, and I say that carbon is 7, and so 12. Hydrogen is 14 times 1, which is 14. Oxygen has mass of 16 times 2 of them, right? 94 grams, 14 grams, and 32 grams total. And then what do I do if I don't find the total mass? I have to add it. So when I add it, I get 108 plus 32.
Actually it's 84.
Where? Oh, it is 84. Sorry. So that's what? 98, right? 98 plus 32. Is everyone writing this? Okay. Oh, I'm sorry. Can you see it? You can't see it? Okay, do me a favor. Can you guys move to that corner? Okay, Jay can't see. 130? Can everyone confirm that? 130 grams. That's the mass of what? The total, right? That's the total thing. So, I'm going to go ahead. I'm going to replace this part. Can I erase it? Not yet? Okay. So the mass of 7 carbon, 14 hydrogen, 2 oxygen, they all add up together to 130. And that's exactly what we did on Monday, where we found the molar mass, right? Okay. It's 84. 98, I did the math wrong, add them together. Okay, the total mass we know is 130 grams. Now, when they're asking for the percent composition, it's asking for the percent composition of carbon, hydrogen, and oxygen. So, just like the pie, we took a quarter's mass, right, of the pie and put that over the total thing. So all we have to figure out is take the mass of all the carbon, all the hydrogen, all the oxygen, and put it over what? 130. So, we know that the total mass is 130. For carbon, I'm going to use pink. 84 grams is the total mass of 7 of the carbons, all the carbons that's in this, right? Do you see where I'm getting at? Yeah. So if I want to find the mass percent of carbon, I simply take 84 grams, put it over what? 130 grams, and then times 100. And that gives me the mass percent of carbon. Okay, so stop writing really quick. Tell me verbally, how would I find the mass percent of hydrogen then? Raise your hand. Richard. Over 130, times 100, because 14 is a mass of all of the hydrogen that's in here, right? And I'm going to put that over the total, which is 130. So it writes out as 14 grams divided by 130 times 100. Now, Julian, how do I do oxygen?
You take 32 over 130 times 100.
Yep, that's exactly right. And then, whatever the numbers I get for this one, and this one, we say that that's the percent composition of carbon, hydrogen, and oxygen in this molecule. Does that make sense? Okay. Yep. So when I do this, it should be 99 point something else, right? It's close enough. So when I do the math for carbon, hey guys, quiet down please. You have 64.62% of carbon, I'm going to put hydrogen in the calculator, so 14 divided by 130. I get 10.77%. 10.77%. For oxygen, I have 32 divided by 130, and then I get 24.62. So when I add them all up together, by the way, when I'm asking for percent composition, do not add these, right? Because I'm not asking for what is the total percentage. I know what the total percentage is going to be. It's going to be 100. But I'm talking about what is the respective, every single atom. What is the percent composition of those atoms? So I have 64.62 plus 10.77 plus 24.62. I get 99.59, which rounds up to 100. So that's a good way to check your math. Because if they don't add up to 100%, then you did something wrong. Make sense? When I add these percentages together, it's out of the total, right? So they should all equal to 100. But if they don't equal to 100, then you need to check your calculation. All right, let's go to the next problem.
If you got how much? 100.
Don't worry about that one. All right, so which of the following compounds has the greatest mass percent of oxygen? So, first things first, what do you need to do? If I want to find the total mass, what do I need to do before that? I need to do what? How can I find the mass of each element if this is not written out? So I need to find the what? Formulas, right? So go ahead and write the formulas. Let's read over this. So, first thing I do is I have to find the total mass, which is what I did. So I'm starting out with the first off, writing down the equation. And we did that. Okay, carbonate has 2 minus charge. Nickel has positive 3 charge. So you crisscross it, and this is the equation that you get. Ni2, parentheses CO3, 3. Total mass. So I like to write everything out. So nitrogen I know has 58.69 grams for every one of them. But there's 2 of those, so I'm going to have to bring down this 2 and then multiply to that. And I get 117.38. Let's go to carbon. Carbon, I find out from the periodic table that it has 12.01 grams per mole, right? But there's how many of them? There's 3 of them, so I have to bring this down and I have to multiply by 3, I get 36.03. I do the same thing with the oxygen, 16 grams. Well, remember, the 3 is going to multiply to that 3. So you have total of how many oxygen? 9. So we're going to do 16 times 9, gives you 144. To find the total mass, what do? Add them all up, and you get 297.41 grams. Now, okay, gotcha. So, the percent, I had a dyslexic moment, and I wrote 297.14. It should have been 41, right? But the point is that you take the nitrogen's mass, right? Divide it by the whole thing, multiply by 100, you should have gotten something along 39.50, right? But remember, I made a math error, so it should have been something else. So, 47, good. So this is supposed to be 41. I do the same thing with carbon, and then I divide it, multiply by 100, and what do I get? 12. Do the same thing with oxygen. Take all of my oxygen mass and divide it by 297.41, and I get 48.42, right? Okay, that is how you find the percent composition. Make sense? Okay, now, I'm going to erase this. Okay. Lithium phosphate, yeah. Don't worry about rounding, guys. I'll tell you on the quiz or test when to round it, okay? But for now, I want you to focus on whether you understand the concept so you can get to that answer. So lithium phosphate, I have LiPo4. But remember, I need 3 of the lithium because PO4 is 3 minus charge. When I find the total mass, I get 115.79 grams. For lithium, I do 6.94 times 3, because that's where I get 3 of them, divided by the total mass, 115.79. You should have gotten 17.98% for lithium. For phosphate, you should have gotten 26.51%. For oxygen, you should have gotten 55.27%.